In this video, we're going to talk about how to use Desmos to find the equation of a line of best fit for your scatter plot. And we are also going to talk about what's called a correlation coefficient. All right, yesterday we talked about how correlation shows how two things are related to each other. And that relationship is going to be in between a -1, meaning that it fits exactly in a negative trend. So it's exactly linear with a negative slope. And positive ones, like 100%, all the points are on a positive sloping line. The closer you get to 0, the further apart the points are from the line, and it shows that there is no relationship between the two things. Next, I'm going to show you how to use Desmos to find that line of best fit. And with any line, we are going to find the slope, the y-intercept, and then we're going to find out what that correlation is. In this next section, I'm going to show you how to use Desmos to find that line of best fit that fits your scatter plot. If you go to our homepage on Canvas, and there's a little folder that says calculators, click on that, and we are going to use this Desmos graphing calculator. This is the assignment we are doing today. I'm going to walk through a few of the questions with you. In class, we are doing this on paper. If you are at home and you can't print off the worksheet that I have posted to Canvas, you can just do the work on a piece of paper and then give it to me when you come back. All right, first step, you are going to click the plus symbol up here in the left-hand corner, and we are going to create a table. We are going to put in these x and y values as our coordinates. So my first coordinate, x, is -20. And the easiest way to get to the next spot, you can click if you like using your mouse, or you can just use the tab button on your keyboard. And 66, -11, and 39, -7, and 27. And finally, 5 and -9. Now, if I come over here and I change the zoom of my scatter plot, I can see those points that I just plotted right there on the side. Okay, we need our equation. We're going to click right here in this box that has a number 2 on it. I'm going to click in there. And we're going to type in a formula that will give us an equation of a line. Normally our equation is y equals mx plus b, right? We want an approximation though, because this isn't exactly a line. And instead of using just regular x and regular y, we're going to use the names that are in the table. We have x1 and we have y1. So our equation is y1, so just type y and 1, and the 1 will automatically become the subscript. Instead of equals, we're not finding an exact thing, we're finding an approximation. So right next to the 1 key is the tilde key. So you're going to push shift and the tilde, so it's an approximation of mx1, so type x and 1, and then plus b. And we see that line of best fit goes through all the points. So this actually is a perfect line. Looking over here, it gives us some values. This right here, the r squared, we won't use that. That's something that you'll use in statistics later. So don't worry about r squared. We're just going to look at r. R is the correlation coefficient, so how closely they're related. Because it's a -1, that means that the points, all of the points, are on the line of best fit. So it's 100% linear in a negative trend. Okay, so our r is -1. So for number 2 here, we're going to put in r equals -1, which is a d right there. The slope right here, the m, that's our slope. So we would have y equals -3x, and then our y-intercept is 6, so plus 6. The equation of this line of best fit is y equals -3x plus 6. And if you look on your options right there, it's that one right there. Y equals -3x plus 6. All right, let's do another one. So I'm going to delete this table because I want to show you what happens when you delete it and you just make a new one, a new table. It didn't change it. Sometimes it'll change that so that it says a 2 on it. If it does that, you can just click on it and change it back to a 1. All right, so let's take a look at this next one. So our coordinates this time are written as pairs in the parentheses. So we have -1 and 2. And we have 0.5 and 4. And we have 2 and 5. And we have 3 and 20. Okay, this time I'm going to zoom out just a little bit so that I can see my points just a little bit better. And we see we have kind of an upward trend, but they're not exactly linear this time because it kind of does a little jump up. So our R is probably not going to be as close to 1 this time. So we're going to click on 2 and we're going to type in that formula for the equation. Y1, the tilde button, mx1 plus b. And we see this time, there's our line of best fit right there. Our correlation is 0.8, so our points are close to the line, but not exactly on the line. So there's a close relationship, it's just not exact. And then with our slope, it is 3 and we're going to round to the nearest hundredth, so 2 places after the decimal. So 3.82, that's our slope. Our y-intercept here, 3.45. So our equation that we're looking for is y equals 3.82x plus 3.45. So it's that one right there. All right, let's look at one more type of problem. So I'm going to delete my table and I'm going to make a new one. And this time it did change it to y2 and x2. So I am just going to click and I'm going to change that back so that it says 1. Okay. All right, when y is 6, x is 2. So my coordinate is x is 2, y is 6. My second one, when y is 9, x is 5. So my coordinate is 5, 9. My next one, when y is 17, x is 8. So my coordinate is x is 8, y is 17. Okay, so we click on the second box, we type in the formula y1 tilde mx1 plus b, and we can see that we're pretty close to the line with those points. So that's why that R is really close to 1. So there's a strong relationship. So we want to look for R is 0.97. So right there. That's what we would put right there in number 10. And then our slope, we would round it to 1.83. And our y-intercept is 1.5. So we have a slope of 1.83. Y equals 1.83x plus 1.5. So there's our equation right there at I. Okay, so once you find all of your equations and your correlation coefficients, you're going to crack the code down here. And then there is one more where they don't give you the coordinates, so you have to pick them out. So let's do one of those, just so you can kind of see how it works. So I'm going to get rid of my table and my line. Okay, so I'm just going to put the coordinates. So that coordinate is 1, 1. That coordinate is 2, 6. That coordinate is 3, 4. That coordinate is 4, 0. That coordinate is 5, 1. And that coordinate is 6, 5. And we can see that looks pretty close to right there. And I'm just looking at the graph, I can tell that there's not a very strong correlation at all, if there is one. So we're going to click on the 2. So our R is not going to be very close to 1. We do y1 is approximately, or the tilde, mx1 plus b. And like I thought, our R is 0.02, so that means that they're not really related at all. There's no correlation. Okay, our slope, 0.03. Our y-intercept, 2.73. So our equation that we are looking for would be this one right here. Y equals 0.03 x plus 2.73. And then once you've found all your equations and your correlation coefficients, you'll do the riddle for that. Okay, so by just putting the letter that you get for each problem. All right, if you have any questions, you can send me a message and I am happy to help you. Have a good day.